In this iMachining tutorial series video 5, we will go over defining a tool and its parameters related to iMachining. This will include the tool's diameter, cutting length, and number of flutes. Then, we will discuss parameters such as the material database, tool material and cutting speed, the default machining level, and helical angle. This video will use the same SolidCAM part file that we used in video 2 of the series, SC Aerospace Part 11.prz, and can be opened from the training folder that we've created on our C drive. By clicking on the Add Milling Tool icon, we can select the type of tool to create for the operation. We will select a flat end mill for this example. Working from top to bottom, we must set the cutting diameter. We will use a 12 mm diameter tool. Next, we will need to set the cutting length. This is important. We will use a tool with a 24 mm cutting length. The Technology Wizard uses the cutting length to calculate if multiple depths are needed to achieve the pocket depth. Setting the number of flutes is also important. The correct number of flutes will assure the proper chip size is given to each flute. We will use a tool with 5 flutes. The iData tab in the tool table is used to define parameters specific to iMachining. The material database will be automatically selected using the part default. Although, it is possible to set a different material database for each tool. Selecting a different material database is used when machining different materials in one CAM project. A fixture is a good example of this. Let's leave the default for now. Selecting a tool material adjusts the cutting speed for a given type of material from which the tool is made. The default is carbide at 100%. By selecting a different material, a percentage adjustment will be used to calculate the maximum cutting speed. An override checkbox is provided, so a percentage adjustment can be set manually as well. For this example, we will select carbide for our tool material. Setting the default machining level will position the slider in the Technology Wizard to this level when selecting this tool. Let's use level 5 for this example. Setting the helical angle is important for calculating depths based on axial contact points, or ACPs. There are 5 typical end mill angles to choose from, or we may also type in a value. For this example, we will use a 45-degree helical angle. After clicking Select, let's make sure the pocket depth is set to 30 mm in the Level section of the Operation Manager. Now we can go to the Technology Wizard and see how values were calculated based on tool information. Looking at the output grid, we can see the Technology Wizard calculated 2 steps at a 15 mm depth to give us the 30 mm total depth. Notice the ACP value is set to 2 and the depth is painted green. Now let's look at a fully modeled end mill and see where the 2 ACPs come from. Here is the tool with a depth of 15 mm. We can take a sectional view of the contact area of the tool. Not counting the bottom point, we can see there are 2 contact points lined up vertically. This is where the 2 ACPs come from. The green color for the depth in the output grid indicates this is a good situation for stability. Now let's change the pocket depth to 5 mm The ACP value is 0.7 and the depth is painted red. Let's look at a model with a depth of 5 mm to see how the flutes line up vertically. There is no contact point above the bottom of the end mill. The 5 mm depth is only 0.7 of the next contact point. The red field indicates that this is not a good situation for stability. Now let's change the pocket depth to 13 mm. The ACP is now 1.7 and the field is painted yellow. A model with the 13 mm depth shows us that there is one contact point above the bottom and 0.7 of the next. The field is painted yellow because we have at least one contact point above the bottom of the tool. Since there is at least one contact point, the situation for stability is okay. Now let's change the pocket depth to 14 mm. This gives us 1.9 ACPs and paints the field green. Although the depth did not give us a perfect 2 ACPs, there is a 20% tolerance on any ACP over 1. 0.9 of the next ACP is within the 20% tolerance and the depth gets painted green for good stability. Changing the diameter, number of flutes, helical angle, and/or depth will have an effect on the ACP. The wizard calculates depths based on the ACPs. When specifying number of steps or step-down value, the ACP number and associated color will still be shown. It is not possible to always be machining with preferred ACPs, but by monitoring the ACP values and the cutting results, over time you may find matching a tool to the current depth to get good ACPs is beneficial. And this concludes video 5 of the iMachining tutorial series, where we went over defining a tool and its parameters related to iMachining. Thanks for watching. We hope you've enjoyed these iMachining tutorial series videos. Please stay tuned for additional videos with information regarding iMachining.